Pertraction, liquid membrane extraction, phenomenon. Pertraction is a liquid membrane-based extraction process that uses a liquid membrane as a barrier to selectively transfer solutes from one liquid phase, feed phase, to another liquid phase, receiving phase. The liquid membrane acts as both a selective barrier and a medium for transport.
Equipment used: hollow fiber membrane module, contains thin hollow fibers impregnated with the liquid membrane. Feed tank, holds the liquid mixture containing the solute to be extracted. Receiving tank, contains the receiving liquid that collects the transferred solutes. Circulating pumps, circulates the feed and receiving phases on either side of the membrane. Liquid membrane, a selective organic phase that dissolves and transports the desired solute. Principle of pertraction: the process of pertraction is driven by the concentration gradient of the solute between the feed and receiving phases. The liquid membrane, which is typically an organic phase, facilitates the selective transport of the solute by absorbing it from the feed, diffusing it across the membrane, and desorbing it into the receiving phase. The efficiency of this process depends on the solubility and affinity of the solute for the liquid membrane. The driving force is the difference in solute concentration between the two phases, feed and receiving. In contrast to other membrane processes like reverse osmosis, pertraction uses a liquid membrane that selectively absorbs solutes and allows them to pass through before desorbing them into a receiving liquid.
Driving force: the process is driven by the concentration gradient of the solute between the feed phase and the receiving phase. The liquid membrane ensures selective transport while preventing mixing of the two phases. The mass transfer equation J is equal to the thickness of the liquid membrane, L, multiplied by the diffusion coefficient of the solute in the membrane, K, multiplied by the difference between the solute concentration in the feed phase, Cf, and the solute concentration in the receiving phase, Cr. The separation factor, E plus minus sign, is equal to the solute concentration in the receiving phase, Cr, divided by the solute concentration in the feed phase, Cf.
Applications: wastewater treatment, heavy metal removal, for example, copper and zinc, using chelating agents in the liquid membrane. Pharmaceuticals, extraction of bioactive compounds like alkaloids from plant materials or fermentation broths. Petrochemicals, separation of hydrocarbons, such as aromatics from aliphatic.
Advantage: selectivity. Liquid membranes can be designed to target specific solutes. Energy efficiency: operates at ambient temperatures, unlike thermal separation methods. Continuous operation: membrane modules allow for seamless and scalable operation. Conclusion: pertraction offers a highly efficient and selective solution for separating solutes in various industrial applications. With its low energy requirements and versatility, it remains a valuable tool for modern separation processes.